Hello. Good morning, good day, good evening.
Hello.
Hi, Andreas, again. Less than 12 hours or less than 24 hours we talked yesterday, yeah. So agenda is in its usual place. Let me share my screen and a link to agenda. You can see my screen, yeah?
Hi, yes, we can. Emil
Okay.
here.
Yeah, hi, Emil. Okay, so good. Let's give a few more minutes for others to join. So if you can type your name while we wait, that would be good. Maybe we can start slowly going through agenda and look at.
Sorry about that, Andreas. I kind of think I messed up your company name there. Got mixed up in the middle of the prompt you were typing.
No problem. No, it's correct.
Okay. So the agenda is full today. First item is basically the same thing, action item. We have some action items we took during last meeting, followed by roadmap discussion. Tracy just sent an email to mail list saying that she will be late. So we may leave this topic to the end of the meeting. If we have sufficient time left, we can have a quick discussion on this. If not, we leave it for the next meeting. And a reminder about Google Summer of Code, followed by presentation from Andreas on Captain, and then David will present how they set up pipelines using GitLab. So I'm getting lots of background noise. Okay, so it was David. And yeah, David will present their way of doing CI/CD, establishing pipelines from open source to their CI/CD. And if you have any topics, please add that to the list. We might not have time to cover it, but we take it as the first topic during next meeting. So the action items from last week, let's take a quick look at that. So the first action item was on Tracy, and we have the topic in the agenda today. Let's hope we have time to hear what she thinks about the roadmap. And then there's another action item on Jason Jaroska from GitLab to provide basic examples for GitHub Actions and Circle CI orbs. And I don't see him in the meeting, but we are trying to get someone from GitHub and Circle CI to join to SIG, and then they can provide information about GitHub Actions and Circle CI orbs. So that is going in parallel to this. Tecton notifications proposal wasn't public. I think it is still the case. So we keep it open. And if someone wants to see the proposal, you need to join the Tecton users mail list, and then you get the access to documents, which I did, and it worked. And then a presentation from Jenkins X, Jeremy and Tracy. It hopefully help us to get someone from Jenkins X community to present Jenkins X to the SIG.
So on the Jenkins X one, yeah, I think I'm happy to do that, but probably the next one if that's okay.
Yeah, please look at the schedule.
Yes, I see that one there.
Yeah,
yeah that's fine.
Just,
we'll get that added on.
Yeah, choose one of the 3 weeks and we are good.
Perfect.
Okay, so we can go to the next topic, which is basically the roadmap topic. And as I mentioned, Tracy will be late, so let's park this till the end of the meeting and see if we have time for this. And the next topic is basically a reminder. You might be aware that CDF is taking part in Google Summer of Code, and people are reaching out to CDF for project ideas. Someone reached out to me at least. I directed them to Dan Lopez and Jacqueline from CDF. And if any of you have any idea from within CDF, then I suggest you to contact Dan Lopez and Jacqueline to make it official, and they get that proposal published on the website, and then the students or interested people can take part in Google Summer of Code. And I think all the projects are already doing. I've seen Jenkins has Summer of Code projects on their website, so this is not for those projects, but perhaps in interoperability area if there is no work ongoing in some other project. So that is the reminder. And then the next topic is Captain. Andreas, you will present, yeah?
Yeah.
Okay, let me stop share.
Cool, thank you. So, hi everybody, and thank you for the invitation and that I can present Captain here in this SIG. So I'm Andreas Grimmer, and I'm a technology strategist working at Dynatrace, and I'm one of the main contributors of our open source project called Captain. So let me start with some motivation, and here you can see a pipeline which was really used inside Dynatrace, and this pipeline per se is not really big. It only has 350 lines of code. But what we have observed here is that we are mixing information. This pipeline contained the process, so which steps are needed in order to do the delivery. It also contained information about the target platform, the environments.
So sorry, Andreas, for interrupting. Should this meeting be recorded, Fatih? In the presentation?
I think it is.
Is it recording?
Yeah, I see this red dot on.
Okay, I don't. Okay, sorry. Yeah, go on then.
It's showing as recording on my end as well.
Yeah.
Okay, very good.
Yeah.
I missed that. Sorry. Go on. Please,
So
Andreas.
for me, it's fine if it's recorded. Yeah. Then let's continue. So what we are seeing here is that we are mixing information inside one pipeline. And what we did is we integrated different tools, different plugins into one pipeline. And of course, we had to do the integration, the interoperability between all those tools. And this is fine if we have a single pipeline, but this is probably not the case in a cloud native environment. Here, in most cases, we do have one single pipeline for one microservice. And you can already see here, this does not scale. And what we get are so-called snowflake pipelines. And we have to do this interoperability and these adaptations for all those pipelines. And this is really the motivation why we came up with Captain. So Captain, in one sentence pitch, is an event-based control plane for continuous delivery and automated operations. And this is important because we also consider automated operation tasks. So Captain does not end if the artifact is released in production. Instead, we also consider so-called self-healing actions, and this makes Captain unique. And now I would like to go into a little bit on the core concepts which we are following inside Captain. The first approach is, of course, we are using declarative ways in order to define the delivery and also the automation processes. And of course, these definitions can be then shared across any number of microservices. Furthermore, we really would like to separate the concerns of different peoples. So in continuous delivery, we do have different roles, different people involved. For example, SREs really care about the process. DevOps engineers care about the tooling. And finally, of course, we have the devs, which should only care about delivering good artifacts, good new software. And another core concept which we are following inside Captain is that we are using an event-based approach. And here, different tools can simply register on a type of event which they are interested in, and then can do their actions. And finally, of course, we do have a built-in observability, which means we can trace the delivery process from dev until an artifact is in production. And we do this with a tool called the Captain's Bridge. And for most of these core concepts, we will now see how we implement this within Captain. So the first declarative approach we are introducing in Captain is the so-called Shipyard. And the Shipyard now only defines the stages which are needed and what to do in the stages. But we do not see any tooling yet. So for example, in my in this Shipyard file, which I have here on my slide, we do have a single stage, which is called hardening. And we have defined also a single workflow, which we named artifact delivery. And here we have to do the following 5 tasks until we have released a new artifact. And with this approach, we clearly see that we are defining a Shipyard in a declarative way. And this is the place where the SREs can, for example, add a new security stage because they need it for security scans or something like this. The second approach, or the second concept we are following, is the so-called Captain's Uniform. And here the Captain's Uniform really defines the tools which implement the steps, the tasks, which we have before seen in our Shipyard. And therefore, you can here list your services. In my case, for example, I've listed here a deployment service, which really only takes care about deploying a new software artifact. And therefore, this deployment service, where I use Argo in the background, registers to a certain type of event which it is interested in. And when it receives it, it takes over on this information and does the deployment. Here, I added a second tool, for example, for doing performance tests. I'm using Gmeter. And you can see here again, this uniform file should mostly be touched by our DevOps, which should care about the tooling. And you can already see here, each of this tool can register on a certain type or on a list of events which they are interested in. And now, in order to implement these tasks, which we have seen in the Shipyard, Captain sends out a so-called triggered event for the different tasks. Here, for example, we have a deployment triggered event. This can also be a test triggered event or any other action which you require in your pipeline. And what you can see here is a is a typical cloud event with its mandatory fields like an ID, the source where this event comes from, and also time point. And in the data block, we can add information which is now required in order to do the deployment. For example, we can add the strategy which should be followed. Here we are doing a blue-green deployment, and a Git URL where, for example, the deployment or the Helm manifests are stored. And the Argo service, in my case, now would listen on this certain type of event, on the deployment triggered event. And as soon as it starts the deployment, it sends out an event. So I now started my deployment started event. For example, the Argo service would now tell me I'm now deploying this Git hash. So the Helm manifests with this Git hash, which you can find in this repository. And as soon as Argo now finished my deployment, it can give me, for example, or it will send out the deployment finished event, and it will give me, for example, the URI where I can find the new deployed artifact. And this is now really the mechanism which we are using in order to couple these different tools. Of course, for example, Argo cannot interpret these events yet, but we need a little bit of translation layer, but we are translating this into an Argo call, for example. And now I would like to show you two examples how we can, for example, do continuous delivery with Captain. For example, we can start the continuous delivery by telling Captain, hey, there's a new artifact which should be deployed. This new artifact can, for example, be a Docker image. And first, Captain sends out an event, a update triggered event, and then some service will take care of updating the configuration, for example, in a Git repository, following a GitOps approach. Then Captain sends out again the deployment triggered event. Argo takes over, deploys a new version, the green version here, and then we can run gmeter tests, evaluate the performance produced by these gmeter tests. And if the performance is good, we can release this or promote it into the next stage, or we can trigger a rollback. And this is really similar now also for the remediation use case. We again use the same triple of events in order to connect different tooling, and Captain again controls simply the workflow which is required in order to do the remediation. Here we do not get triggered by a new deployment or a new Docker image. Instead, we, for example, get an alert by Prometheus or a problem event of Dynatrace. And first, we look up whether there is a registered remediation action for this kind of problem. And if so, we can trigger a remediation action. And in the background here, again, you can simply implement the service, which, for example, calls Xmatters, ServiceNow, Ansible, or any other tool in order to execute your remediation actions. And you can be creative which remediation actions you would like to perform. And in the best case, we then evaluate whether the executed remediation action actually helped. And if so, we mark the problem as resolved. Otherwise, we can escalate. Okay, that was Captain in an overview. And now, finally, I would like to emphasize my expectations or our expectations from this SIG. And this is clearly the cloud events which we use in order to connect different toolings. And for example, for Captain, it would be really helpful to have a common set of events, for example, for doing the deployment, testing, and so on. So Captain addresses this interoperability between different tools by using events. And of course, if we can standardize this set of events, or at least the type of the events, this would already help us. So now I would like to answer all your questions.
I have a question. So thank you for that, by the way. It's good to see other companies are kind of going down the same path as what a lot of us have already been thinking about. I understand the event-based mechanism that you just introduced. Makes a lot of sense in a lot of ways. However, the developers that I'm dealing with traditionally have expected to have a tool that, or even just, it doesn't need to be a UI, but at least something that shows them the end-to-end steps of a pipeline. So that, including, by the way, including what should happen if something needs to be remediated. Does the definition mechanism that you have, there's a few different kinds. I can't remember exactly what they were. Do they include the complete set of tasks, or is it all based on events which then get triggered? And how do you see the whole thing end to end?
A really good question. So the events are generated or sent out based on this definition of the workflow, which we here call artifact delivery. In our case, Captain would send out. So if this workflow is started, Captain sends out an update triggered, and then in the background there are one or several tools registered for this update event, which then take care of updating. And as soon as all of these tools reported a finished event, Captain would then go to the deployment, to the next task. So would send out the deployment triggered event. So yes, we can predict the flow or the set of events. Does this make sense?
Sort of, except that, like, for example, even just the definition of what I'm looking at here, I'm trying to equate what I'm seeing here to an in-house tool that we ourselves have developed versus something like Tecton CD, which I'm sure you're already familiar with. So this kind Shipyard, would you say that it's equal to the pipeline? Can I say that a Shipyard is equivalent of what we would find as a definition of a pipeline?
Yeah, a Shipyard contains the information of your stages, and each stage can have multiple workflows. And again, a workflow consists of a set of tasks. So I would say, yeah, kind of. This is true, yeah.
From my not really knowing too much about Captain, it seems kind of like it's one level up almost. From what, because I would almost imagine having like a pipeline for, like, if I was using Tecton, like I would have maybe a pipeline for deployment or a pipeline for update for the things that you're calling tasks, maybe, or maybe it would be individual workflows. I'm not sure. Maybe it'd be like artifact delivery would be one pipeline, but I don't know. It seems kind of like, it seems like this is a thing that's linking together multiple pipelines with events. That's sort of how I'm viewing it. I don't know if that's accurate.
That's true. Each task is basically implemented by one Docker image or multiple Docker images, and so yeah, we are level up. That's true. We do not, for example, have steps.
I see. So it's Shipyard. Then Shipyard has stages, multiple stages, and each stage has a workflows, and then each workflow can have tasks. Is that correct?
That's correct, yes.
And the syntax, I'm just looking like under tasks, you have a task called update and then colon, but nothing follows it.
Yeah, this is an array of objects, and if you would like to pass in some metadata like strategy blue-green, you can do this. It's not a list or an array of strings, it's an array of objects.
Of objects, okay. Got it.
I have a question.
Oh,
Go on, Christy.
You go.
Okay. I noticed some on the slides. I think you mentioned about Argo. Is Captain kind of tied with Argo, or is there? Are you looking to also use a Tecton to run these tasks? If that makes sense.
And that would, from an architecture perspective, really make sense, because each task could be a Tecton task here. As yeah, I'm not that familiar with Tecton, but yes, this could be implemented that way.
Cool. Yeah, I was just wondering if that's something that you're looking at doing. I guess maybe.
What?
Okay, no, that's good. Thank you.
I have a couple questions. One thing I'm trying to, it feels to me like the way that I'm seeing this, I've divided up in my head into like two pieces, but maybe they're more interrelated than I'm imagining. But the two pieces that I'm imagining are the part about defining an interface for the events that systems are emitting, which are being linked together. Like if you wouldn't mind going to one of the slides that has like one of the use cases. Yeah, like this one. Let me start over again. So in this use case that you're showing here, there's a shipyard that defines this entire thing with the update and the deployment and the test and the evaluate. Is that right?
That's correct, yeah.
And then I guess the part that I'm not totally following is that then you said that the tasks are Docker images. I'm kind of surprised because I thought that the idea was that like you would be emitting an event or something that would be consumed by like Argo CD in this deployment example here, and then Argo CD would be like emitting an event when it was done, and then Captain would be continuing on from there. Are the events, like I guess is the interface to these tools the events, or is it the images that are invoking the tools, or is it both?
So in the best case, Argo would understand the events, but currently it does not. So we built a wrapper around Argo, which can interpret the event and then can start an Argo synchronization and Argo deployment. And that's the reason why here we do have an image that invokes Argo. Okay, so the images, it's not so much that like, the goal isn't that you're like plugging in an image that like runs JMeter. The goal would be that you're specifying something that can use events to interact with like JMeter. In the best case, JMeter would understand out of the box our cloud events, and using the information of the cloud events would trigger its tests and would report back a cloud event if it's done. Okay. Now I have another question to add on to my queue of questions. I'm so sorry. The next question I have is, you mentioned your goals for this SIG would be to define like a common interface, and I was surprised to see that you wanted to define like common for each like type of, you had it divided into types like deployment, test, like different sort of scenarios, and I was wondering like how much Captain needs to know about, like, does Captain need to know it's a test event, or does Captain just need to know it's a cloud event? Like I'm wondering why it's important to have common interfaces for each type versus just a common interface for anything you might be doing. So Captain does not need to know which type of event it's emitting or it's sending. for Captain, this is not relevant, but the information which is encapsulated in the type of the event is really helpful. For example, for monitoring tools. If you know when there is a new version deployed, you can really make a versioning in the monitoring tool, like Dynatrace or Prometheus. And therefore, having a common set of events would help tools like a monitoring tool in order to understand what's going on in the background.
Okay, yeah, that makes sense. Thank you. And then probably my last question, do you have any interest in, I've noticed some use cases like this being mentioned here as well. And I was one sort of attribute that these scenarios have that I think is interesting, and I'm wondering if it's something that you want to support or actively don't want to support, is the idea of being able to enter one of these, like, so like in this slide, this would be, I'm just looking at the Shipyard, this is like a workflow. Would you call this like the representation of a workflow?
Yeah.
So like, would you want to be able to enter the workflow at different points, or do you want to only be able to start it at one point? Because I guess by nature of it being like an event-driven system, like you could maybe imagine a scenario where like you manually run Argo CD or something and it emits an event to be like, I finished. And then would you want to enter the workflow from that point, or do you only want to enter it from like the starting point when the new artifact is made?
A really good question. So the goal should be to always run the complete workflow, but if you did this update by your own, you can directly jump into the deployment. Yeah. So it's event-based, and Captain should finally recognize it so that you started the workflow in the beginning or entered the workflow in the middle. But per se, per design, we would like to start it from the beginning.
I see. That's an interesting choice, because some systems have made different choices. I don't know if you've seen Concourse at all, but that's like one system that seems to take it to kind of the other extreme, where you can kind of enter a workflow at any point if one of the artifacts that's being watched changes. Yeah, so just interesting. I'm still trying to figure out my opinion on like whether it's a good idea or not. It seems like it's confusing. That's my one like kind of criticism, is that when you can enter at any point, it seems like harder to reason about like what's happened in the past and what will happen. But yeah, those are all my questions. Thank you very much.
Cool, thank you.
I have some follow-ups if nobody else. I'm sorry, go ahead.
Yeah, just leaning on from that one, from a governance perspective, we want builds to be deterministic. But with a distributed event-based architecture, you can't guarantee that. So I wondered what your thoughts were in how you manage that scenario.
If you do not change the tooling in the background and you do not register some new tooling, which, for example, would register on the deployment triggered event, you can be deterministic. So you exactly know which tools are in the background, which tools listen to this kind of event. So
yeah, what you can't guarantee is perfect knowledge about whether a message was sent and processed, lost on the way, or the response was lost on the way. So you can never know what the true state of the remote system is.
yeah, but for this, you can use some strategies like at least one strategies which are implemented in PubSub implementations, and with this information you can guarantee that you at least get the events and that no events are lost.
Well, not necessarily. That's the challenge in this space, is that once you go into distributed events, there is no perfect scenario where you can guarantee that you have complete information about everything that's happened.
I have to admit, then probably we can I cannot think of a case now where we would lose an event, but yeah, probably we can discuss this offline because
Actually, just from the kind of a answering back to Terry there, I suppose you could you could build some tooling. I don't know if Captain already has it. Build some tooling that basically goes through, looks at a shipyard, looks at its workflows, its tasks, and sees, okay, we know from the underlying system that each one of these tasks produces this type of event, and you can then figure out what event listeners that are already registered, and start to build out a graph of actions that actually are supposed to take place. I understand your point about, yes, what happens when you lose one event is lost in the middle, and obviously the thing that's supposed to listen to it never receives it, it never picks it up, it never happens. But at the very least, you can come up with a predictable, you can predict what would happen if this whole shipyard thing was to fully execute. But I still go back to Andreas. I have a question for you. Where does someone go to look at what has happened?
A quick follow-up on your last comment. So we need this anyway to know what events do we expect, because otherwise we would not be able to do a synchronization. For example, if we have multiple testing tools, we would not know when to start the evaluation. For example, we have functional tests and performance tests, which are executed in parallel. And because both tools register to this test triggered event, and we can only start the evaluation if both completed. So in Captain, we of course already know this when to continue the evaluation. So regarding your second question, this was, can you please repeat it? So.
Actually, it's sort of, let me follow up on what you just said. So you already know the graph of actions that are expected to be executed as a part of this shipyard. Is that, I'm getting that correct?
Of part of the shipyard, and of course we need the uniform. In the uniform, we exactly know which event listens to a triggered event, and we expect each tool to also send a started and a finished event.
Okay, so that you already have that. Okay, that makes sense. Do you have any place that a developer would go to see the full graph of actions in one view? And once again, it does not need to be UI. It can be just some JSON or a YAML that says, based on your shipyard and based on your uniform that you've registered, here's what we expect to happen. There's the what we expect to happen, and I would imagine that someone would want to ask the question of what did happen actually when this, at this time this took place, at this time this event was fired, and because of this other thing took place. And you understand where I'm going with this?
Good point. So we do have what took place. So the past we can show the user in our so-called Captain's Bridge. Unfortunately, I do not have any screenshot here, but the prediction what will happen in the future, the user cannot get this information yet, but of course we know that we need it going forward.
So, sorry guys, apologies for interrupting, but we have one more topic and we invited David from Orange. The discussion and questions and responses are great, but we really need to move on. But one last comment question perhaps to Andreas. You will continue joining the SIG meetings, and we can continue discussions around Captain and event-based approach, yeah?
Sure, I would love to. And
Yeah.
thank you for this great discussion.
Thanks. Thank you everyone for the questions. Sorry again. So let's move to the next topic, David.
Hi everyone, can you hear me?
It's really difficult to understand.
It's difficult to understand me, okay.
Yeah, there's so much.
Many noise, is it better now?
Kind of better.
Is it better?
No.
Yes or not?
No.
No, sorry. Sorry about that.
There seems to be super gain on your microphone or something.
How is it now?
Better if you speak a bit loudly, then it will be a lot better.
Loudly?
Yeah.
Okay.
Actually, you went really quiet. Now you need to
Yeah.
turn the gain back up just a little more.
Okay. Now, is it better?
Much better.
Okay, great. Okay, can you see the slides?
Yes.
Yes. So first, thanks to invite me to this meeting. I will just show you how we are dealing with installation from bare metal to VNF for virtual network functions in Orange. This is in the labs for now, but we hope to go to the production in the next years. So Orange is a big telco company. We are more than 100,000 people inside the company. It's an old company. We need to replace many bare metal servers that are dealing with calls from all the circuit calls to the next 5G networks. We are dealing with many Terra routers, with many things on the internet, from the fiber to the old technologies. And we have many vendors inside our network. So we must deal with everything with a very heterogeneous network, heterogeneous technologies, and heterogeneous competencies inside Orange, because we are an old company and we have many people from several years inside, and they don't have the same level on the new technologies. What was the start of our CI reflections? We first work on OPNAV project from the Linux Foundation with Fatih, and our experience on that project was that we were working on the deployment of a big telco YAS, and we deals with project with installer that were really monolithic installer that were doing everything with a big shell script, and they were dealing all the parameters, all the steps, everything. So they installed from the bare metal servers to the OpenStack, and it was quite complex to work with those projects. And the Jenkins was in a separate place. So inside our Orange, we did not appreciate that, and our needs at this time a few years ago was to create hardware resource that can be long, complex, and may be the base of further deployments. We want to install an OpenStack that can be adjusted for a few hours or for several years. We need to deploy a Kubernetes or a VNF for testing or for a long time. And at each time, at the end of each steps, we need to reuse the function that we deploy. And so we had to change several steps, several projects. We choose to use GitLab CI because we had it internally in Orange. It was the reference tool inside Orange. It already it already proposed CI simply and natively without extra servers. But GitLab CI is much more monolithic project. It can trigger another project, but it's quite complex and not easy to deal with artifacts. So back to the basis, we just set a few projects where we just have input project with input parameters and files. The code is totally agnostic to where it will be deployed and what will be the parameters. There is the goal inside Orange was to avoid project with hard-coded parameters or really parameters that were linked to one kind of environment. So we work on that part with the project, with the people dealing with the internal project to avoid that kind of code. So we push to have project that accept inputs that can be environment parameters, that can be files, and create artifacts to use the resource that were created. Each project had to deal its own CI/CD steps. We don't want people from another team or somewhere else to say you must use that, and we don't want to have long meetings to install complex environments. And we want to have artifact archives where we have the login, the password, URL, the build results, everything, and that can be encrypted. Our choice was so to break the big monolithic projects. One function with a fixed parameters. We don't want to have a big project that are doing everything from bare metal to the VNFs. We just want to have one CI/CD config by project. One project, for example, that will deal with the creation of a VM. One other project that will deal with the installation of a bare metal server. They are separate, splitted projects, and each project know the best how to deal with that. It's not another project, another pipeline everywhere, somewhere that will say you have to deal with that. We want to easily replace one project by another, so we have to simplify the input and the output and to have something homogeneous between the project with the same function. So in theory, like other project, we have a step with a scenario configuration that create a set of files. We create a Jumpos prepare, for example. That was for installing OpenStack. We create a jump host that will create files with the infrastructure description and the jump host credentials. We deploy the operating system on the infrastructure. So we have a new set of files with the credentials, the jump host credentials, and the infrastructure description. We deploy OpenStack with a specific project. We have now an OpenStack admin credential, and we test at the end the OpenStack. So that was the theory. If we want to go now to the practice, we just have a set of different projects in GitLab. We have a config project, we have an infra manager project that we create and deploy the bare metal servers. We have a collab project. It's just a wrap up around the Cola OpenStack installer. And we have the FunTest project that will test the OpenStack. At each time, we are dealing with the input and the output of the project. So we can deploy OpenStack on a VM or on bare metal. We just have to replace the project, not to deploy with Infra Manager that is dealing with bare metal, but OS Infra Manager that is dealing with OpenStack, for example. We can also have different steps for Kubernetes deployment, still with the scenario configuration, creation of VM, deployment of Kubernetes, and testing of Kubernetes. We also have the same thing, the same suites of step for ONAP. ONAP, that is a VNF orchestrator. So we have the configuration files for the scenario, the Kubernetes preparation, the ONAP deployment, and the ONAP test. We work inside Orange to at each time test each final result with the automated project. Sorry for that. And of course, we can chain the pipelines of pipeline. We can, by simple click, deploy OpenStack on a bare metal, then deploy Kubernetes. So deploy OpenStack, create VMs, deploy Kubernetes, test Kubernetes, deploy ONAP, test ONAP, then deploy VNF, etc., etc. So all of that can be triggered by a user, can be triggered by a cron simply, or can be triggered by a Gerrit commit. On several, as we are dealing with different with inputs on the project, and that those inputs are creating artifacts with the project. These artifacts are the input of the next steps. We can deploy now, we are deploying on several infrastructure, on several OpenStack. We're also deploying on Azure and the Wind River lab in the US. Each time we are working with GitLab that is managing the pipelines, managing the jobs, everything. What's again, Orange is dealing with many vendors. When I say we are working with projects, it's mainly projects that are triggering or installing vendors scripts or vendors applications or vendor VNFs. So it's mainly wrap-up scripts that are working with other applications. So the idea is to manage the chain of the pipeline, the chain of those pipeline, and to let the vendor's application work in this own project. So we worked on a GitLab project, a Git project that's called Chain CI, that is a scenario manager that is dealing with the pipeline of the pipeline. It's a trigger of other GitLab projects. This project, GitLab, the Chain CI is preparing a set of input data. It fetch the results of the pipelines and create the new input of the next steps. Each time we can encrypt, we can deal with the SSH config and key preparation to work on several infrastructure. I will switch the sharing to show you a little demo. Feel free to ask me some questions if you still can hear me.
Yes, we can.
I actually have a question. Is this tightly related to GitLab then? It's not possible to connect other projects upstream or downstream that don't use GitLab, is it?
Can we use another project than GitLab?
Yep.
Yeah, no, it's really using the GitLab API. So of course you can call another API, but for now it's only linked with the GitLab. You can have several GitLab. We are deploying with the same scenario. We are dealing with internal GitLab and external GitLab. We are on GitLab.com on our Orange GitLab. For example, in Orange GitLab, we are deploying our bare metal servers and the OpenStack, and on GitLab.com, we are deploying ONAP. So, can you see the Firefox page?
Yeah, sure.
Yes. So this is a simple GUI. It's quite easy. I assume that I'm not a web developer. That shows the different steps of a scenario. Here we are on the gating for ONAP. So each time the people on the ONAP project, on project, is creating a patch, it's deploying automatically on our infrastructure. So here we can just click on the, it's not the best example, this one. We can click on a step of the meta pipeline to see what is inside the other pipeline, the other project. So this project, the project, has its own GitLab CI file. It's the manager of the project is the only one that can deal with, that knows what to do with its project. So the idea, as we are using in Orange many teams that are dealing with just one equipment with a specific vendors, we have to split the projects, and each people managing a project is responsible how to deploy this function. So for example, we have the several steps here to deploy the project, and we can click simply on this step to go on the GitLab to see what is going. So it's quite easy to go from one pipeline to the others. The project here is on gitlab.com. You will have the links to see that. So for example, sorry, I will show you a scenario file to deploy on Apple Alto on our podcast. This is the configuration. So we have the scenario steps with the first step, that is a configuration. Then we will have a step that is infra deployment, that will call the project OS Infra Manager, that will get the configuration, some artifacts from the previous step, that is config. And we add extra parameters to GitLab. Those parameters will be sent to the project OS Infra Manager with the file generated previously and with those specific parameters. At the end, we will deploy, we have the app deployment that will mix artifacts from infra deploy, the previous step, that will mix infra deploy pipeline from other projects or pipeline from specific places. And at the end, we have the step for the application testing. Still mixing artifact if we want to do that.
David, I have a question there. You mentioned like when a patch comes into ONUP, you trigger jobs on your GitLab chain CI. How do you connect like ONUP with your pipelines? Because ONUP uses Gerrit, I think.
So we just have a simple application that you can find here. I will just show you that on the LFN open source projects in Orange. On the CD part, we have an application that will trigger, that will have the webhooks from the Gerrit, and that will create a waiting queue, and then start GitLab or GitLab chain CI just by another webhook. So it's just a waiting queue and a call of another webhook with a specific parameters.
Okay.
So I'm pretty sure that it's not amazing for you, but for our point of view in Orange, we have to deal from bare metal servers that are quite complex and heterogeneous, and we have to deal many projects and split the responsibilities of each project with some specific people. So it's not we don't have canary, we don't have some canary testing or something like that, because some applications don't have enough traffic to be tested in canary. Some other network functions are historical with a complex data inside, and that can be stop and start like actual web services. So it's maybe a little more complex, but we are dealing as we can with by splitting the project. For example, if we want to describe what we want in this installer, this is one of the configuration that we can send with the PDF and IDF from OpenEV that we kept. So this file is describing how we are deploying the VMs, etc., etc. Everything is a configuration inside that project.
David, we have 1 minute left, so
yeah, I will be quick and finish my slides. Just So our goal was to have a high modularity, to do not have any servers to install, because all the people in Orange don't know how to use or to install server, don't want to manage a specific server. So we want to use the maximum possibilities from GitLab to decentralize everything. We want to trigger from complex projects that are dealing with the installation of OpenStack or Kubernetes to simple projects that are just a simple deployment of a DNS or a web application. And we want everything as easy as possible. And of course, as we are deploying from GitLab.com, we are encrypted the artifacts, the inputs, and the specific login and passwords. Of course, this project is not simplifying the GitLab CI. People that are creating their own project and want to be triggered have to understand how to use GitLab CI. This is this is a significant ticket fee, but they are only have to deal with the installation of their project, and it's from inside Orange. It does not prevent to understand how to access the resource or to pass the proxy and everything like that. For now, GitLab Chain CI, the project is mainly in Ansible. The other projects that are triggered are mainly in Ansible 2. It's historical, but we are deploying a new version in Python that is under test, and we want to enhance the environmental usage in GitLab and to rebuild the interface if we can. But as we split all the project and push the good practices inside Orange, Chain CI may not be the solution for us, even if we think for that in production for deploying big VNFs. But as we have split all the project, now it's much more easier even to replace Chain CI. So that was the goal, to have something clear on the automation parts. You can find all the code and all the example here in GitLab.com.
David
Yes.
and Andreas, if you can upload these presentations to CDF presentations repository on GitHub, then people can look at those presentations and browse the websites or the code you have there. That would really help. And the recording of this meeting will be published on YouTube as well. And I don't know if anyone has any question. We are already over time. Sorry to interrupt, David, but thanks a lot for the presentation. Any questions? One last question. Okay, I take this as no. So thanks again, David. And our next meeting will be on 19th of March, and we will have a presentation from OpenDev by Jeremy Stanley on Zool. So please don't miss that as well. And thank you all for joining today, and talk to you next time.
I'm hoping I'll get the slide deck for that sent out to the mailing list next week, so it can be circulated in advance.
That would be great. Thanks, Jeremy. So thank you all. Sorry for our time, and have a nice day, evening. Talk to you next time.
See you. Bye.
Thanks. Bye.